merge case sorted list. So for this problem, you'll be given an array of linked lists, and each of those linked lists are stored in a sorted order, and we need to merge them to create one master linked list. So yeah, there are many ways to solve this problem. The easiest way I found is using a priority queue. So what we do is essentially we traverse all the nodes in all of the indexes of the array. We store it in a priority queue, and then we keep removing elements from the queue, and then we use that to generate basically a master linked list. So yeah, it's pretty simple. Let's try coding it. The first thing we're going to need is the priority queue. So by default, the values in the queue, since we are defining them to be integers, they'll be stored in ascending order. Now we are going to traverse each of the nodes in the linked list. So we'll use a for each loop for that. And for each of the nodes, we're now going to traverse all the values inside of the node. So for that, we'll create a separate while loop. So yeah, the logic here is simple. We're just now adding all the elements from all of the nodes inside of the priority queue. So next step is now to generate the master result queue. So for that, we'll create two pointers. One is the head and one is a temporary pointer, which will be used to create the different elements inside of that linked list. So this method is just used to return the element from the front of the priority queue. So essentially what it does is it returns the minimum element every time. So yeah, let's recap. First thing we are going to do is create a priority queue. We are going to add elements from all of the nodes inside of that queue. And then we keep removing elements and then use it to generate the values of the master linked list. So yeah, let's try running it. Oh. Hopefully I didn't make any other mistake. All right, all the use cases are passed. We'll try submitting the solution. So yeah, the time complexity. So imagine n is the length of the array and m is the size of each of the nodes, the size of the linked list in each of the indexes. So the runtime complexity will be nm log n into m. And the space complexity, since we are creating a priority queue to store all the elements, it'll be like, a combination of n into m.